All right. Hopefully you had a good 3-day weekend or 4-day weekend. So spend a couple days talking about section 9.7. Today we're going to do what's called law of sine. So every other section in this chapter we've dealt with right angles. So now we're going to deal with what happens if you need to figure out the length of a side or something, or an angle, and it's not a right triangle. Okay, so first, that's when we're going to use law of sine and law of cosine. Today we're just going to do law of sine, and tomorrow we'll do law of cosine. So law of sine says sine of angle A over side A equals the sine of angle B over side B, which equals the sine of angle C over side C. You're going to use 2 out of those 3. So we're going to set up a proportion using 2 of those. Okay, so if we had a triangle like this, and basically we're going to be solving the triangle. So figure out basically what's missing. So we're going to figure out what's AB. We're going to figure out what's angle C. And we're going to figure out what's angle B. All right, and 2 out of the 3 will be some work, and the 4th one, or the 3rd one, will be just to add up the angles to make them equal 180. So that shouldn't be very difficult. Now, when do I use law of sine? Okay, use when you know an angle and the side across. So I have 115 degrees, and I know the side that's across from it, the 20. So if I have that, law of sine is way easier than law of cosine, just first. So you're going to have to use one of the 2 no matter what. But law of sine is a lot easier. So and so really we're going to be able to write a proportion. So we're going to say sine of 115 degrees over 20. And then really the only other thing I know is the 11, which is the side across from angle B. So that's what we're going to be figuring out. And if you wanted to write X right there instead of angle B, that's totally fine. It's just a placeholder. So, all right. So first, sine 115 degrees, 0.9060, or excuse me, 9063 is sine of 115 degrees. And that's just 20. And again, if you want to write X, that's fine too. Okay, and then we're just solving the proportions. So 20x equals, let's see, that decimal times 11, 9.9694, and then divide by 20. Point 4984. Okay, so that's not the angle. So remember when we talked about last week, when I'm trying to find the angle, I then have to do the inverse. So if I have a decimal and I'm trying to find like the angle, we get 29.89 or 29.9. So we got to solve the proportion, and then at the end, because I'm trying to find an angle, I got to do the inverse. Okay. All right, so angle B ends up being, maybe I should have used green since that's what I wrote up here, but 29.9. So then to figure out angle C, I can just do 115 plus 29.9 is 144.9. And when I do 180 minus 144.9, I get 35.1. So that part should be simple. All right, so now I'm missing, I still need to figure out AB. And so I have to do law of sine again. Except now I need to use this 35.1 because that's the angle that goes with the side down there. Okay, so on every problem, I think I said it, but if not, you're going to have to do law of sine twice. So, and I would go back and use, so if you did sine of 35.1, then C is on the bottom. I would go back to using the 115 and the 20. Just because 29.9 technically is rounded off, so is 35.1. So the less numbers that you use that have been rounded, the better. So sine 35.1 is 0.5750. Sine of 115, we just did it, is 9063. Okay, so multiply the diagonals, and we get 0.9063C equals 11.5001. And then I'll divide that by 0.9063. And I get 12.6890. So remember, I got to do the inverse of that. Oops, I must have typed something in wrong. Let's see. Sine. So I was just double checking my work, and I did kind of forget about something here. It does round off to 12.7, and that is the answer. So you might be asking, like, well, why did you do inverse on the one side and you didn't on this side? So sometimes when you have like 115 degrees, like it's a bigger than 90, and that's kind of the main one that you're using, you don't know the other angle. So remember, like on the red one, I was figuring out an angle, so I do inverse. On this one, I'm figuring out a side, so there's no inverse to do. Okay, it's just 12.7 for that side. Oops. 12.7. Okay, so pretty involved problems. You know, they take, excuse me, a little bit of time to figure out on some of them, because you got to do this law of sine thing a couple times. Okay. So this is how one problem will look, where you have two sides and you have an angle. So let's go back to this one. 115 is, and then 20 is across from that. So then 35.1 and then 12.7 and 29.9 and 11, those are fairly close, but 35.1 and 29.9 are fairly close. But they do go like in order. So 20 goes with 115, 12.7 goes with 35.1, that's the next smallest side and angle, and then 29.9 and 11 are the next smallest side and angle. So that's a way to just check. That'll prevent like a huge error from occurring. It's not going to prevent a small inverse. Okay, like we did down here at the end. Okay, because we were figuring out what was angle B. If you're figuring out a side, then when you finish the problem and you get, you know, C equals or B equals or A equals, then you're good. Okay? All right, give it a shot, because we get one where you have two sides and one angle. Or excuse me, two angles and one side. Oops. So let's say we had okay, so let's say we had that one. So I said you use law of sine when you know an angle and you need the side across from that angle. So it would appear in this problem that that isn't the case, because the side that's AB, the 6, goes with angle C, which I don't know. Angle A goes with this side BC on the bottom, which I don't know. And 82 goes with AC, which I don't know. So you might think, well, then how is this a law of sine problem? Well, it's a law of sine problem because I know two angles and I can figure out the third angle, and it's probably not the greatest like drawing. I probably should have made the 82 a little bit smaller, but you know what, we're here so far. So C is 9 degrees. So if you know two angles, no matter, before you even try to figure out is this law of sine or law of cosine or whatever, figure out the third angle. Like, that's always going to be a good choice. Okay, so now I do have an angle 9 degrees, and the 6 across from it. Excuse me. So I can do sine of 9 degrees over 6. And then I just got to figure out, like, technically this is the B side over here, and this is the A side over here, because it's always the lowercase letter across from the angle with the uppercase letter. It doesn't matter which one you do. You want to figure out A, you want to figure out B, it doesn't matter. So I'm going to do B, sine of 82 degrees over B. So remember, we're figuring out a side, so I don't need to do inverse or anything like that. So first I'll figure out the sine stuff. So let's do sine of 9 degrees, 0.1564 over 6, and sine of 82 degrees, 0.9903. So we multiply the diagonals. 0.9903 times 6, 5.9418, and then divide. And we get 37.99, so that's really 38.0. You might think, like, why do you have to put the 0.0? It's indicating that it's rounded off. If I got just 38, that's indicating that that's the exact answer. So it's a small technicality, but all right. And then we're going to do the same thing again. And again, I would use sine of 9 degrees over 6 because those are exact answers. 38.0 is rounded off. You'll get a slightly accurate, more accurate answer. So sine of 89 degrees over A. So it's kind of the same process. Sine of 89, 0.9998. You know, it looks remarkably the same if you kind of compare the two, except I have an A instead of a B. 5.9991. Divided by 0.1564, and we get 38.35 or 38.4. Okay, so like I've typed in all this stuff and figured things out, and how do I know if I did it right? Well, you don't know 100%, but one thing has to happen for you to at least be in the ballpark. So the longest side has to be across from the longest angle, or the biggest angle. So 89 is the biggest angle, across from that is 38.4. So 82 across from that is 38.0, so it is smaller. So that has to happen. And then the 9 degrees is across from the 6. And so you notice, like, these 38 and 38.4 are pretty close together because 89 and 82 are pretty close together. And the 9 degrees is way off, so the answer should be a lot smaller. Okay, you know, your answer can still make sense in that kind of quantitative way, like, okay, the biggest angle is the side across from that is still the biggest. But it is a kind of a way to check, like, a pretty large mistake. Okay, so you've got 6 problems. Because, yeah, each one of them does take quite a bit of work. And I will tell you that 3 of them 1, 2, 3, 4 of them are like the second example where you have two angles and you can just figure out the third, and then you can do sine, law of sine again. And then the other two, you'll need to start with law of sine, but you're going to have to figure out one of the angles. So remember, when you're figuring out an angle, you got to do this. We're going to talk about law of cosine tomorrow, but you're going to do law of sine once in those problems. Okay, so practice these, ask questions if you don't get it, and we'll go over them. You know, with a little bit of practice, these do kind of, it's work, but I think you guys can get it. So, all right, have a good one, and we'll see you tomorrow.